Hello. Okay, so just so everybody knows, I am currently on 2 streaming platforms right now. I am on YouTube and Discord. So I'm putting a little Discord invite in the chat room, and if you are interested in being on the Discord channel, you can do that. But if you want to just stick around on YouTube, that's fine too. You can do either one. So I'll just make a note of that in the chat. So streaming on YouTube and Discord. If you would like to use your microphone to ask questions in real time, feel free to use the Discord link above. And can I pin that? I don't know if I can. No, I don't think I can pin that. Okay, that's fine. So we'll just wait for a few more people to log in. Say that again. I can hear you now. Yeah, there you go. Okay, let's see here. So looks like we have 1, 2, 3 people on Discord, which is cool. So you can hear me. So my Discord is a bit of a mess right now because I was just using it for calculus. But we'll see what that turns into. Okay. Okay. But if you're on Discord, can you see the screen and everything okay? You can see me and hear me and everything? Okay, perfect. Okay. Okay. So if you're not on YouTube, someone just asked, are we going to have quizzes and stuff online, like homework? And my answer is yes, we are going to talk about that shortly. Okay. Okay, so we have 6 people on YouTube. We have 3 people on Discord. So I'm gonna wait another few minutes. I'm gonna grab a snack and oh, there's one more person on Discord, so that's good. Yeah, so just in case you didn't know, when you're on Discord, there's a little button at the bottom to mute your microphone. So if you've never used this before, It'll be a learning experience. So you can just click the unmute button if you want to actually say something. But if if you listen to music or something, then it's kind of nice to mute your microphone. So but yeah, if you do want to say something, then yeah, just unmute your microphone and then just start speaking, and it should be able to pick up your voice pretty quick. Okay, so I'll be right back. How are we doing the tests and quizzes? Good question. Okay. Okay, someone asked, how are we going to do the tests and the quizzes? Well, I'll talk about that. I'm going to put some information up on the website. It's going to be done with a program that you can use on either your phone or a computer. And the gist of it is that you'll be getting a digital assignment, and you'll be taking a photograph with either your webcam or your phone camera or what have you, and then you'd submit that to me. Okay, so that's how it would work. The program is called CrowdMark. So that's the software that we're going to use, and I'm going to aim to have some more information on my website shortly. So have I posted that worksheet I mentioned? No, I have not. Sorry about that. I'll aim to have that up by the end of the day, so you can have some work to do. So what are we gonna do today? Let's talk about that. So, got a little Word document here. Come on. Okay. Yeah, okay, so I think what I'd like to do is just do some examples from section 4.4, and I'd like to assign some homework from 4.4. Does anyone have any questions that they'd like me to address beforehand? I'm just going to check my email here. Okay. see here. I don't think I got any messages. Let me see here. Okay, yeah, I don't think anyone here has messaged me at all today. So yeah, I'll just choose a selection of problems from your book, and we'll kind of go through them together, and then I'll assign some other questions for you to work on. Okay, so we're going to be working on 4.4. Okay, let me find a spot for the book. Okay, here we go. Let's get started then. So yeah, this is just going to be kind of a sort of a practice session. So we'll call it section 4.4 practice. Okay. So we're just going to be practicing some use of the quadratic formula. So just recall, we're gonna be using this formula a whole lot. Maybe you've had the opportunity to memorize it. It's when ax squared plus bx plus c is equal to 0, we get that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is the quadratic formula. So we're going to be using this quite a bit. Also, it's worth pointing out the discriminant. So the discriminant is b squared minus 4ac. And I believe yesterday we had the opportunity to look at the effect that the discriminant has on the actual graph. In particular, when the discriminant is negative, you have no roots, or in other words, there are no solutions to this equation. If the discriminant is equal to 0, you have exactly one root. And if you have a positive discriminant, it means that you have either two roots or two solutions to this equation. It all means the same thing. So those are our three possibilities. So let's just start off with question 1. So I'll do just kind of a random selection of questions. So I'll do let's do 1C. Let's do 1C. Okay. So that one is r squared plus 9r plus 6 equals 0. Oh, and I guess I should write what the actual question is. So the question is, so use the discriminant to determine the nature of the roots for each equation. Okay, so I'm just going to write how many roots. How many roots? Do not solve the equations. And then we are going to check the answers graphically. So I'm going to use a graphing calculator. In particular, I'm going to use Desmos because that seems to be the one that's easiest for me to use. So I'm going to start off with how many roots. And what did we say 1C was? R squared plus 9r plus 6. Okay. And that's equal to 0. So in this case, a is equal to 1 because there's no coefficient in front of r squared. So I'll just keep it as a 1. B is equal to 9 and c is equal to 6. So the quadratic formula says that x is equal to negative b, and b is 9, so we've got negative 9 plus or minus the square root, make this a little bit bigger, of b squared, so that's 9 squared, so 9 squared minus 4 times a, which is 1, times c, which is 6, like this, all over 2 times a, which is 1. So that's what the quadratic formula says. But keep in mind, this is kind of overkill. We don't need to know all of that. All we need to know is what's in here. So what's going on with the discriminant? So the discriminant, I'm just going to write disc, that's going to be 9 squared minus 4 times 1 times 6, or in other words, 81 minus 24, and that is, 80 minus 25 is 55. So what is this going to be, 57? I think it's 57. Okay, in any case, it's positive. It's positive, right? So yeah, so in this case, since the discriminant, so I'm going to write that this is greater than 0. So therefore, we have 2 roots. Okay, we have exactly 2 roots. So in this case, we had a positive discriminant. That means that we have 2 roots. Let's quickly go and graph that. So I'm going to head over to Desmos and graph this. And what did we have? It was r. I'm going to use x instead of r. It doesn't really matter which variable we use. So I've got x squared plus 9 x plus 6 plus 6. And would you look at that? We have exactly 2 roots. We've got one here and we've got one there. Keep in mind that we didn't calculate what those roots are. We still don't know exactly what those points are. I mean, we know now that we've graphed them, but we the algebra that we've done so far doesn't tell us what those roots are. It just tells us that we have 2. Okay, let's do another one. So let's do 2c. So 2c. And 2c is how many zeros do we have? So how many zeros do we have? Okay, and in this case it's a function, so we've got f of x equals, and I'm doing 2c, so that's 1/4 x squared minus 3x plus 9. So I'm asking, how many zeros do we have? Okay, well, if we want to talk about zeros, we're saying, okay, when is f of x equal to 0? So we'll have, no matter what we get, we'll get 0 equals 1/4 x squared minus 3x plus 9. So our discriminant is still going to be the same thing, and it's still going to tell us the same information. It's just phrased in a different way. So if I'm talking about the zeros of a function, I'm also talking about the roots of this polynomial, right? So this portion right here being the polynomial. So this is a polynomial function. So a polynomial can have roots and a function has a 0. So but they mean exactly the same thing. It's just that over here in this one we weren't talking about a function. We were just talking about a polynomial equation, in which case we refer to these things as roots. But now that we're in the world of functions, we can ask exactly the same question, except we have to use different words because we're talking about functions and not polynomials. It's a polynomial function, but it's still a function. So we're still going to use the same discriminant. So the discriminant is, so I'll just write disc. So the discriminant is b squared minus 4ac, and b squared, well, that's going to be negative 3 squared minus 4 times a, which is 1/4, and c, which is 9. So this gives me positive 9 because negative 3 times negative 3 is positive 9, minus, well, 4 times a quarter is 1, and 1 times 9 is 9. So I've got 9 minus 9, and that's equal to 0. So because I have my discriminant equal to 0, what that means is that we have, and this is obviously equal to 0, so I'll write therefore we have exactly 1, 0. Okay, and let's verify that in Desmos. So let's see what that looks like. So I've got 1 quarter x squared minus 3x plus 9. Okay, and look at that. We have exactly 1 root. Sorry, 1, 0. Yeah. So yeah, does that make sense? Is that okay? Yeah, okay. So we're just using the discriminant. It's just like before. It's just we're using different words. It's the same process. We're just calling it something else. Sorry, your microphone is cutting out. Can you say that again? Yeah, the quadratic formula is just like a shortcut. Yeah, so it'll tell you exactly what those roots are. So if we wanted to use a quadratic formula, okay, so let's, even though it doesn't ask us to do this, and I think it actually tells us not to do this, but let's just do it anyways. So the quadratic formula is going to say that in this case, if we want to know what the zeros are, well, we can use the quadratic formula to find those zeros. So it'll be negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, this is equal to, well, negative b in this case is positive 3 because b is negative 3, so negative b is positive 3, plus or minus the square root of, well, we already know what the discriminant is. The discriminant is 0. We calculated that already, right? So we don't need to calculate that again. And then all over 2a, so I've got 2 times a quarter in my denominator. So this is equal to 3 plus or minus the square root of 0. Well, the square root of 0 is 0. And if I add or subtract 0, it doesn't change anything. So this is just 3 on the numerator. And on the denominator, I've got 1/2. 3 divided by 1/2 is equal to 6. So that means that our 0 is at, well, or my x value is 6, and my y value, well, it's obviously at 0 because we're talking about where the function is equal to 0. So that would be the x-intercept of this quadratic. So that's it's all consistent. So that's why, I mean, hopefully this kind of tells you why we have this idea that if the discriminant is equal to 0, then we have exactly 1 root, because this just turns into 0, and then this plus or minus thing, it doesn't have 2 answers now, because plus or minus means that we actually have 2 answers. One answer where we add, the other answer where you subtract. But if at each point you're adding and subtracting 0, it doesn't matter if you add or subtract 0, you get the same thing. So that's kind of where the discriminant plays a role in the number of roots that we have. And of course, if you have the square root of a negative number, well, then you're solving for something that doesn't exist. So yeah, obviously we would have a problem there. Okay, let's try. Let's say, let's skip ahead a little bit. Let's try number 5. Let's do 5C. Okay, so we've got negative 2u squared plus 16 equals 0. Okay, so in here we're asked to determine the roots of each quadratic equation and then express our answers as exact values and to the nearest hundredth. Okay, so we're looking for roots. Looking for roots here. Okay, so let's see here. So in this case, so we could use the quadratic formula if we wanted to. There's certainly nothing wrong with that. I'm gonna do it in two ways though. So in purple here, I'm gonna do it using the quadratic formula, and then I'll use a different color, and then we'll do it in a more straightforward way. So in this case, I know that keep in mind that there's kind of like a invisible plus 0 u here. Don't forget about that. So what that means is that a is equal to negative 2, b is equal to 0, and c is equal to 16. So if we're looking for the roots, then we're going to use the full-blown quadratic formula. We're not looking for the number of roots. We want the actual roots. We want their values. So what are these roots? Well, the roots are the following. So we've got, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, I'll make this a little bit bigger for you. So x then is equal to, well, negative 0 plus or minus the square root of 0 squared minus 4 times negative 2 times 16 all over 2a, and that's 2 times negative 2. So that gives us that x is equal to 0 plus or minus the square root of, well, 4 times 2 is, negative 4 times negative 2 is positive 8. 8 times 16 is, I think, 128. So this is going to be the square root of 128 all over 4. And is that right? Is it actually? So that's 2, 1, and 4, 3, 7. Yeah, I think that's 128. So this is really just that x is equal to plus or minus the square root of 128 all over 4. And I can simplify this a little bit. We haven't really done any work with radicals yet, but guess what? That's what's coming next. If I wanted to, I can simplify this. This is going to be the square root of 2 times the square root of 64 all over 4. And the square root of 64 is 8. Where did I go here? Here we are. So the square root of 64 is 8. So this is equal to the square root of 2 times 8 all over 4. And we all know that 8 over 4 is 2. So this is actually equal to 2 times the square root of 2. Oh, and I forgot my plus minus symbols here too. Don't forget, this is plus or minus, and then this is plus or minus 2 times the square root of 2. Okay? And in the question, they're actually asking us to give us the exact value. So this is the exact value. And it also asks us to calculate a decimal version of it. So I'm going to go ahead and use my calculator to take the square root of 2. Come on. Square root of 2. The square root equals, and then I multiply that by 2. And I get about 2.828. So this is equal to, I'll just write a little squiggly. So x is approximately equal to, 2.83. Okay, because we're rounding to the nearest hundredth. Okay, so that looks okay. And again, I forgot my plus and minus. So this is plus or minus 2.83. Okay, so let's take a look at the graph, and after that, I'm going to show you the other way, because I told you that we'll solve this in two different ways. So let's take a look at this graph and just make sure that we're kind of on the right track, that we got 2.83. So the graph was it 5C? No, there's no way that was 5C. Yeah, which one did I do? Yeah, that was not 5C. Sorry about that. That was 7C. Yeah, I solved 7C. Sorry guys, this was 7C. I'm not sure where I made that mistake. So this is 7C. Oh, and that's perfect because it asks us to solve using an appropriate method and justify your choice of the method. So I'm gonna do it in two ways, and then you can choose which method you think is easier. So this would be the quadratic formula. Okay. So let's just take a look at what this function looks like. We've got -2 times, and I know that the variable is u, but we're gonna call it x squared plus 16. Okay, and what did we say? It was like 2.83 or something? 2.83? Yeah, 2.828. Yeah, so that is consistent with our work. So that's cool. Let's find the other one, or calculate it the other way. So the other way I'm going to do it is with factoring. Okay, so there's several ways you can attack these problems. So I'm going to write the question out again. I've got -2u squared plus 16 equals 0. Okay, and now what I'm going to do is I'm going to factor out a -2. So I've got -2 times u squared minus 8. That's all equal to 0. And because it's all equal to 0, I can do this really nice thing where I just multiply both sides by -1/2 times -1/2. And I do that because -1/2 times 2 is just 1, so that cancels with that. And then this cancels with that because 0 times anything is 0. So I'm left with 0 equals u squared minus 8, and I don't even need brackets. So in other words, u squared is equal to 8, and u is equal to the square root of 8, which is actually equal to 2 times the square root of 2, which is exactly what we had before. So I guess that's actually not technically factoring. I kind of just solved it, but it's close enough to factoring that I think maybe you get the idea. I mean, really what I was doing here was I noticed that this was a difference of squares, and a difference of squares is going to look like this. I've got x plus the square root of 8 and x minus the square root of 8, and that tells me that one of these has to be 0, so that means that x is equal to the square root of 8, or x is equal to the negative square root of 8. And then once again, I forgot that I need to include my plus and minus symbols here. So again, we have two solutions, so I have to be aware that I'm going to have a plus and minus for these. Okay. Okay. Any questions about that? I know that that was a lot of algebra all kind of thrown at you at once, but it's good to go through these questions. Yeah, you're good. Okay. Yeah. How do you factor fractions? Okay. So let's. You mean like when you're completing the square, when there's a fraction in there? Okay. Okay. So let's do an example where we're completing the square and we have a fraction in there. Let's see here. Just trying to find a good example. Okay. So I'm gonna do this example. This one's from your textbook. This is on page 250. It's not an exercise. It's just one of the examples that they have here. So this is on page 250. So so let's see if we can factor. Let's factor. I'm going to adjust this a little bit. I'm going to adjust it just a little bit. Let's factor x squared minus 7/3 of x plus 4/3. Okay? Oh, hold on just a sec. Okay, so let's factor this guy. So we've got some fractions in here, which is it's kind of nasty. So what I'm going to do is I'm going to set this equal to 0. So I'm going to say that this is x squared minus 7/3 of x plus 4/3, and that's equal to 0. The reason I'm setting it equal to 0 is what I'm going to do. I'm going to solve for x here. I'm going to say if I can figure out what x must be to equal 0, then I can use that factor along with this one where if a times b is equal to 0, then a equals 0 or b equals 0. This is called the factor theorem, by the way. The factor theorem. So we use it enough that it kind of needs its own name. So it's called the factor theorem. So we're going to use any solution along with this, and you'll kind of see what I'm doing here. So we're just going to complete the square, and then we'll write it in factored form. So I'm going to complete the square first. So I'm going to think of this middle term right here, and I'm going to cut that in half and then square it. So I'm left with x squared plus 7/3 of x, and then I'm going to have, well, negative 7/3 times a half squared. Well, that's equal to negative 7 over 6 squared, which is equal to 49 over 36. So I'll add 49 over 36, and then I'll subtract 49 over 36, and you'll notice I made a little typo there. That should be a minus sign out there. And then I have plus 4/3, and that's all equal to 0. And I'll put this in a different color so you can see that all of this junk is separate from the other junk. So this right here is going to be a perfect square. So I'll write PS because it's a perfect square. And it's a perfect square because, well, we made it a perfect square. We completed the square. I know that if I take the square root of this guy and then double it, I'm going to get this guy right there. So what it means is that this is going to be x minus 7 over 6 squared. And where did the 7 over 6 come from? That is what is inside these brackets. So we already calculated what we're subtracting from x. And then everything else, everything in yellow, is going to look like this. So I've got 49 over 36 plus 4/3, or negative 49 over 36 plus 4/3. So if I multiply the top and bottom of this by 12, then I'll have a common denominator of 36. So I've got negative 49 plus 48, so that's negative 1 over 36. So I'll bring the 36 over to the other side, and I'm left with, well, I've got x I don't know why this is a 6. This is supposed to be a 2. So I've got x minus 7 over 6 squared equals 1 over 36. And now I'll take the square root of both sides, and I'm left with x minus 7 over 6 equals plus or minus 1 over 6. Because the square root of 1 over 36, that's equal to the square root of 1 over the square root of 36, which is equal to 1 over 6. So I'm just going to write it as plus or minus 6. And now I've got x equals 7 over 6 plus or minus 1 over 6. And a nicer way to write that is that x is equal to 7 plus or minus 1 all divided by 6. So those are the solutions, but I still want to write this in factored form. So that means that x has two possibilities. X can be either 7 plus 1 over 6, which is 8 over 6, or in other words, 4/3. Or x is equal to 7 minus 1 over 6, which is 6 over 6, or just 1. So those are my two possibilities. So what I'm trying to say is that if those are the possibilities for x, then I can have x minus 1 and x minus 4/3, and that's going to be equal to 0. And now I've written it in factored form. I know that this is a true equation. I know it's true because if x equals 1, if x is equal to 1, well, then I'm going to have x minus 1, or 1 minus 1 is equal to 0, and that whole equation is going to equal 0, and it makes this equation true. The other possibility is that x could be equal to 4/3, and if x is equal to 4/3, then in this portion of the equation, I've got 4/3 minus 4/3, which is 0, and 0 times anything is 0, so we would also make the equation true. So there I took a quadratic that had all sorts of fractions in there, and then we wrote it in factored form. So that's how we would go about doing that. So does that answer your question? Okay. All right. So I think that's pretty much all the examples I wanted to do. So for homework, what I'd like you to work on is the following. So homework, I'd like you to work on page, what is it, 254, page 254 to 255, and I'd like you to do numbers 1 through 14, okay? So that's your homework for today. What was that? I think someone said something in the chat. Okay. So there's definitely some challenging problems in here. I don't expect them to be like a walk in the park. So if you do come across any questions that you're stuck on, let me know and we'll address them in our next class. So we're just going to kind of just trudge along here and do our best. I want to take a minute to sort of talk about CrowdMark. So CrowdMark is a program. Oh, that's not it. Let's do CrowdMark. There it is. Okay, so here's CrowdMark. You don't need to sign up. I'm going to sign you up already. Some of my grade 10 students had a little bit of difficulty logging in, so we may have some difficulty with that. In any case, we're going to give it a shot. So this is the program that we're going to use for online assignments and things like that. I haven't used it before, so I can't speak to like how well it works, but from what I understand, it's kind of like one of the better programs out there. I know that this is what they're using currently at the University of Winnipeg and the University of Manitoba. So some of the big institutions are using it, which is usually a good sign, because in that case there's so many instructors and professors and stuff that if it wasn't a very good program, they probably wouldn't use it. So it was recommended to me by one of my old professors who reached out. So I'm gonna give it a shot. We'll see how it goes. And so I've got all of your email addresses. It's going to be done through your Winnipeg School Division email. So that's how we're going to do assignments going forward. So yeah, I'll put some information on the website today, and we'll see how that goes. So in the meantime, what you can do is just work on this homework. And I'm going to put sort of like a test assignment. Not test is a bad word. Sort of like a trial assignment, so that you can try the program out, see how it works. We'll kind of find any flaws that we might come across. I just want to make sure that things go as smoothly as possible. So keep your ear to the ground about CrowdMark, because I'll be putting some stuff on the website shortly about how to access CrowdMark and the sort of things you can expect to see on there. So I think I'm going to leave it at that. So there's about 20 minutes left of class. I would recommend spending that time working through a few of these questions. And if you have any sort of concerns about anything, don't hesitate to reach out either on Instagram or I guess Discord now, or email or what have you. And if it's kind of like a big question, then I'll address it in tomorrow's class. Anyway, I'm gonna sign out and end the stream. So I will see you guys tomorrow. I guess you'll see me. Okay, bye bye.